My name's Amos. If you saw the first talk, I helped introduce Quinn, and I also get the distinct pleasure today of getting to hang out with Frank. And I have to say, Frank, that's a wonderful picture of robots in the background. And Pierre, who has the best shirt of the conference so far. I think I'm pretty excited to hang out with you guys and hear all about embedded systems and hardware development and how that's working in Erlang and Elixir. And I hear that there are books and hardware coming out and all kinds of things. So welcome.
Thank you. So how should we start?
Thank you. Yeah.
So on everybody on the call, if you have questions or anything, and just feel free to unmute yourself and ask questions. And other than that, I can just make it up as we go along.
So about that question, would we see the Q&A section, or do only who sees it? Because I see nothing at the moment.
I'm looking in there, but I don't see any questions, but people can also verbally ask questions. I guess, we could just go ahead and get out of the way. The question on everybody's mind, since you're here, and we already talked about it a little bit, is when is the GRiSP 2 coming out? Because we're all pretty excited about it.
Really soon now. So we had some holdups for those who didn't follow it. As everybody else was making electronics, the parts crisis also hit us a bit. Including Brexit, because we ordered some connectors from a distributor in UK, and they got actually stuck in customs, as you read it in the newspaper, because of Brexit. And then they went back to the supplier and disappeared there. But we have the boards. We have the boards in the right amount. So the hardware is here, and we currently need to adapt because the hardware changed quite a bit from the first prototype to the final version. So we had a lot of little wires on the first prototype and all kinds of things and extra things testing. So we have quite some work to do to adapt all the software. And then we decided to rewrite all the drivers as NIFs because they are super useful when you're directly running on the hardware, because then the latency is much less than with the pod driver, which the old GRiSP had. Basically, the GRiSP drivers so far were pod drivers because you could not use NIFs. On if you want to statically link your stuff, this didn't work, but that works since a few years thanks to the OTP team. So we are doing a driver rewrite and everything at the moment, so we're quite busy, and we expect to ship end of November. Finally.
For anybody who doesn't know what GRiSP is, do you want to give a quick little rundown of what it is?
GRiSP is actually a software stack like Nerves, basically. Unlike Nerves, it's a software stack that is kind of like a little bit skewed in the direction of unikernels. So unikernel is when you link together your application and your operating system as a library kind of thing, so not really operating system, into one image and boot this. So you can use this on virtual machines to have very quick boot times, but there's also kind of like what we would call unikernel nowadays on real hardware, like started directly on the hardware, kind of like 30 years ago when all this started, then Artems, the unikernel that we use for that, the word unikernel didn't exist yet, and there were just embedded operating systems or executives. So where did I get here? How do I get out again? Well, why did I tell you this now? Too much in holiday mode. So
it's just explain what GRiSP is.
Yeah, explain what GRiSP. So kind of like the thing that runs on the hardware is this unikernel thing, but the main work is in the drivers, because you need to write device drivers for all these different hardwares, because you're directly running on the hardware. And you directly need to talk to the actual hardware, and not you don't have the advantage, as Nerve says, because it runs on Linux, that it can actually use the low-level drivers if they exist. If they don't exist, you also have to write the low-level driver. So if the low-level driver exists, it's actually less work for Linux-based embedded systems. If the low-level driver doesn't exist, it's probably even more work. because then you have to write a low-level driver and then your Elixir or LLM-level driver to talk to the low-level driver. So that's one thing. And the other thing is the tooling. So we have lots of tooling because we need to build OTP, cross-build OTP. So when you do rebar 3 GRiSP build, then we actually, the thing cross-builds OTP in the background. It might download a pre-built version if you don't add your own NIFs. But if you add your own NIFs, it actually downloads the source code, patches in all the stuff that we need to patch in. There's kind of like certain stuff in certain directories, and then builds OTP, like the Erlang runtime, cross-builds it for the unikernel. So there's a lot of tooling around it. That's a lot of work is in the tooling.
And then the goal of this is for you to be able to write most of the system in Erlang at that point, because that is like kind of the
or
OS.
Elixir.
Or Elixir. Nice.
We support both. So we refactored this tooling that I just talked about into a separate library. And there is basically a rebar version and a mixed version. I have to admit the rebar version is more maintained at the moment because it's the main thing that we use. And I'm not sure if anybody uses the mixed thing. I did not hear any complaints, at least, but that can have multiple reasons. Nobody's using it, or it's perfect, which I don't doubt.
I vote for perfect. That's the way it always is. So how about you, Frank, over on the nerve side? How's that different than GRiSP? Maybe you can add a little there.
Well, I mean, Pierre definitely gave the summary, right? I mean, there are a lot of things that are similar. So the tooling side, there's an amazing amount of work there that we try to hide. So I mean, the point is that we want to live in this happy place with Elixir and Erlang, and I try to avoid some of the details. But there are a lot of details, and I guess on the details, some of the newer things for us is kind of exposing more software bomb, bill of materials kind of information, kind of being a little bit more sophisticated in that, because this is going to be a more and more important thing for people to be able to access. I think to that extent, there's some work going on possibly in the security working group with software bomb pieces. I hope that is coming up, which will be super useful to kind of unify this. I think since we use the Linux kernel, I think we get the benefit on the Nerve side of having some of the hacks get into newspapers and stuff that we have to make sure are patched on the Nerve side before we scare too many people too bad. So having more visibility so that you have a Nerves device, and I guess this applies everywhere, it's just to know that you need to upgrade soon or just be aware of what the ingredients are in your system. So that's been a big deal. The other side on the kind of the infrastructure side on Nerves is to expose metadata for other tools. So the language that's come up recently on the Nerve side for a lot is Ziglang. And that's partly because Isaac Yamamoto wrote this nice package called Ziggler to kind of make these little inline little Zig code snippets that compile straight down to a NIF, and it's kind of transparent. You get like the speed of Zig, just transparent in your Elixir code. So that's kind of cool. But behind the scenes, there's additional metadata to make that magic work. And kind of my hope is now that we're exposing some of this metadata, that other things that are similar to Zig can start being a little bit easier to use just out of the box. So I was looking at you. You look like you were going to ask another question, but
go ahead if you have something to say.
I like a lot of talk. There's like a lot of stuff going on in Nerves land to share. I think if any of you are using Nerves, you probably saw a whole lot of versions get bumped to 1.0. And it was probably a little obnoxious, but it's mostly symbolic. We've had APIs locked for like years because by certain production, it's like totally impossible to change some functions now, even though there are things that we'd like to improve. So the core team went through and we 1.0'd the next set of libraries that were pre that, kind of open things up so we can build on to some like 2.0 features, and on some of the pieces that have, through the production experience that we've gotten, some of the feedback we've gotten, there's some things that we need to do slightly different so we can start getting that out. So I'm kind of excited about that. The other thing, Nerves Livebook is like making progress. Those of you who haven't looked at Livebook, it's basically like code notebooks, like in Python, how you have Jupyter notebooks. It's kind of the same thing. Turns out it's super fun for hardware too. So that's getting some attention in the Nerves community, and I'm of course trying to promote that as much as I can because it's super fun for me too. Let's see. The other thing, I guess there's another book. So Pragmatic Press is going to be publishing another book on nerves soon. There's already one on building a weather station. This one is going to be on building this binary clock, but more of the focus is on how you construct the software for the project. So the clock is kind of just the device to motivate working with hardware, but really if you were to look at that book, you do it for how do you organize software to make it easy to develop and quick to develop in kind of the embedded environment. So that's I guess the top.
There's so much going on. So
Frank, I'm really impressed with your shop, and I love the fire extinguisher.
Oh yeah.
It's out on the desk because he just put something out.
I'm at a disadvantage.
That's hardcore
normally
right there.
Normally
I was a little afraid of something.
Normally I also sit in front of my scope, but I'm on vacation, so this Buddha has to do.
Yes, I have to say that I think you.
So usually I have a corner
location
with books and a scope in the back, and actually, whenever I kind of don't use the scope, I place it conveniently for calls, so everybody knows immediately. Oh, this is the embedded engineer.
This guy knows what he's doing. So Frank, you mentioned lessons learned in production, and Pierre, you've done some production systems too. I'm curious what things can you talk about that are out there in production that are used commercially that maybe some of us I hear all the time that nerves or Erlang, that's like a hobbyist thing when it comes to hardware, and I know that's not true because I've worked on some of it. So I would like to hear you both have a much bigger picture than I do of that world. So if you could share some of the actual companies out there and the projects and that you've worked on or heard about.
Who starts?
Pierre, you want to start? Yeah.
I go first. So mainly we built the GRiSP thing to use it in our own products for our own product development for prototyping, and the board is the prototyping platform that we want to use. Basically, that's its main design goal. That it can be also used as a toy is a nice side effect. Basically, currently we are actually working on a large project for German railways, like DB, the German Railways Company. To have an e-paper display on all small train stations. There will be 6,500 train stations. We are not making the hardware. Somebody else, like a normal display hardware manufacturer that is used in the rail system, is actually making the hardware, but the application software is actually written in Erlang of these things. So we kind of like got our foot in the door at German Railways with Erlang. I hope this can expand. There we actually don't use GRiSP because they forced us to use a certain build root environment that they use for all the displays. So we're actually doing something more Nerves-like because they say, yeah, we want Linux, basically. We need Linux. And it's also, it's okay. For this use case, it's a good platform. So it's because you don't have real-time requirements. We don't need access to very low-level hardware. And we have the display manufacturer is actually making the drivers for this. And I'm very excited that we're making actually new hardware. So we already started a few new hardware projects. So we made 3 PMODs. basically, so PMODs, I need to explain what PMODs are. So the GRiSP board has a bunch of connectors called PMOD connectors, which is a kind of like an industry standard, like a one company standard made by Digilent for little hardware modules to plug in. It's a very low level, lightweight standard. So if you have an SPI or I2C connector, it's just the pins on the PMOD, that's it. And you can make very little cheap boards with not a lot of effort to try out things. And then you can plug it into a GRiSP board, and there's hundreds of PMODs that you can just buy from different manufacturers, actually, because more companies actually make PMODs. And we started to make our own PMODs for the hardware that we are missing. So we started with one for RFID antennas, one for 24-volt industrial I/O, and I will get to why very soon. And one which is very exciting for ultra-wideband radio. That's the new radio that's also in iPhones and recently, which gives you low power but decent bandwidth up to 7 megabits. And it lets you measure time of flight of signals, so you can actually do indoor location. It will be the standard for indoor location. That's what excites us, because we do industrial applications for location. I mean, the RFID antenna is also for location. It's just like more like a one-bit thing. So if something is in front of my RFID antenna, I know it's there. I know now it's there. But if it moves away, I need to kind of like track it. And these PMODs are prototyping things for another hardware, which we currently call industrial GRiSP, which is a new hardware and in a box, which will not include the ultra wideband, because that's kind of like a little bit too far out for industry. They are not so fast. It's more like I can connect one to it. It's more for experimenting. But currently we have basically 8 24-volt IOs, like a PLC. We have an RFID antenna. And we have 2 Ethernets, and we drop the Wi-Fi because the industry likes to daisy chain Ethernet, like you go from one Ethernet to the next, to the next, to the next, and you forward. And you daisy chain the power also, and then you have like IOs. And this is actually made for be used on conveyor belt systems. So this will go into a real factory at Bosch making electric motors. It will go on an assembly line that makes electric braking motors, like the compressor motors for brakes in modern cars, basically, because you don't put this on the chemtrail, but you make an electric motor that actually makes the pressure for the braking system. And that's very exciting for us, because finally we get to a real factory. It's not an experimental, researchy, things go in a loop and you do nothing thing. We did this in the past. So that's why I said I'm not interested in this anymore. We did this. That's actually where GRiSP came from. So it didn't have a name, but that's where it came from. And yeah, and it will be IP67, so it will be usable for other waterproof things, and it will have the same hardware core than GRiSP2. So it will also run Nerves, by the way. if somebody ports it. So you can run the same software, basically. That's why it's called industrial GRiSP.
Sounds like
that
we
will
need
be a real application. This will be a product.
It sounds like we need a stamp. This works with Nerves to put on everything. That's a lot of different things there. Frank, how about you? Where on the Nerve side, what kind of production level systems do you know about?
Yeah. So I was you asked a really interesting question. So like, what are the things that we've learned from production or that people are doing in production that are different than like what's you just get out of the box for, and when you just download Nerves from the website. And the biggest things are recovery from bad software loads and all the logging and telemetry metrics, all that stuff. And so the metrics, that's coming in slowly. If you look, there's a new project called Mobius. It's on Hex. It's the idea for that is there's local logging of telemetry metrics. So normally when you have telemetry, you're kind of pushing all these metrics to the server. That may or may not make sense for your embedded device. So there's a library to store them local and then batch them up if they're needed when they're needed. let you query. So then the logging, I think they're better. There's a little bit more sophisticated logging in the production systems. And another one is what happens when you load, like when you just make some Linux kernel boo-boo, or like you mess up something in your OTP release that makes it crash immediately. And the production systems like will revert to the previous software load, for example, or recover from this, go to a safe mode. That currently, right, is when you get nerves just by default, especially if you're working on a Raspberry Pi. That's like reboot loop time, reload in the take the micro SD card out, upgrade it, or rewrite it. Yeah, so it's kind of a bummer. There are little things, if you look behind the scenes, we're moving that direction to make that more accessible. The Raspberry Pi is kind of a unique, it's kind of a little bit more difficult platform because production-wise, most people are using like U-boot bootloaders, which lets you do a little bit more stuff. So, but if you look behind the scenes, we're getting there. And I'm really hoping 2022, it's like out of the box, revert all this stuff. And it's very easy to see. And I'll take this opportunity, since there's one really good question that I'm excited about on the Q&A, if you don't mind, Amos, which is ARMJIT. ARMJIT was it was funded in part by the Erlang Ecosystem Foundation, finally coming. So, and the question is, will it be in Nerves? The answer is, of course, it's going to be in Nerves as soon as I can get it there, because having a speed up that's almost for free from my point of view is a no-brainer.
I mean,
same goes for
Frank,
GRiSP.
sorry. Oh, that's awesome, Pierre. But is it going to work out of the box? I mean, it should just work, right? If we have Erlang 25. Right?
Everything that I've looked at, I have high expectations. So,
cool.
I mean, we'll see. I mean, I guess it will come out to, so there's ARM. So it depends on which processor you're running with Nerves, right? Nerves supports a whole lot of different processors. So you got to, like Raspberry Pi 4, it's 64-bit ARM, since we run in 64-bit ARM mode, that is probably the first one that you'll see it on. And then the 32-bit ARM, well, I need to check in the status, but we'll have to see how that works. Usually some of the, like Pi 0 gives me a little bit more trouble since it's not quite as good of an ARM.
Yeah, cool.
Yeah, that's also the GRiSP 2 thing, that the current GRiSP 2 hardware is a 32-bit ARM, because we want to be power efficient. We want to be able to run off a battery easily and don't need cooling or whatever. The person that EEF is funding, the Embedded Working Group is funding for making this library, for actually making the kind of like making the JIT assembly, basically the low-level library that actually makes you paste together assembly code that the Erlang runtime uses. That's not something done by the OTP team. They use an external library, an open source library. It's a guy that does crazy things with it, like with graphics libraries. That's why it was actually made for graphics libraries, for speeding up graphics, because you generated the graphics code on the fly. And basically that's one of the things that we extended the funding on, that there also will be a library for ARM32, and then OTP team needs to actually put this in. Well, I need to ask them about it soon to actually get it in soon. And then we can do ARM32. That means then Nerves can do Raspberry Pi 0, and we can run it on GRiSP hardware. And also Nerves can use it on GRiSP hardware then at the same time. That's the main obstacle.
Nice, that's great. I'm pretty sure that we're getting ready to get the cutoff symbol. So I just wanted to, this has been a quick view. If anybody can hop in on Toucan later and continue this conversation. I know I'm really excited about hardware. I want to thank Frank and Pierre and the teams that you work with and the work that you're putting into the embedded systems part of the Erlang Ecosystem Foundation. Your support there has been wonderful to watch, and I just thank you both.